In one of the last videos, we introduced this concept called marginal rate of substitution. Just a quick little blurb. I said the slope of the indifference curve is a marginal rate of substitution, and we're going to get to it in a later video. Guess what? That later video has arrived. And it's in this video that we're going to define what this marginal rate of substitution is. But first, let's recap on what an indifference curve is. An indifference curve looks at all of the different bundles of goods, or the different combination of two goods that will yield the same level of satisfaction. We said that that level of satisfaction is going to remain the same all the way up and down this indifference curve. So by that nature, for us to obtain more consumption of one good, so one must change the consumption of one good to obtain addition of another. So if we're looking at tacos versus hamburgers, for us to obtain more hamburgers but still remain on this indifference curve, we must lower the amount of tacos that we consume. We must give up tacos in order to obtain more hamburgers, or vice versa. We must, if we want more tacos, we must give up more hamburgers because we need to remain on this utility, this ISO utility curve, this indifference curve. So because of that, this marginal rate of substitution looks at what rate are we going to substitute one good for another. So the marginal rate of substitution is the rate at which the consumer is willing to substitute one good for another. How much are they willing to give up in terms of tacos to gain one more hamburger? So the slope of any segment of the indifference curve of any two goods is this marginal rate of substitution. Remember I said that indifference curve, the slope of the indifference curve is the marginal rate of substitution. Well, that's true. That any particular segment of the slope of any segment in this indifference curve of two goods, that's the marginal rate of substitution. So if we look, that slope, it's downward sloping, isn't it? That downward sloping means that slope is at a negative angle. It's a downward negative slope. So the MRS, this marginal rate of substitution, is negative. This marginal rate of substitution is always negative because that slope is negative. So this negative slope indicates that there has to be a trade-off between two goods. So now I've thrown all that terminology at you, and I've said, all right, marginal rate of substitution, that is going to be the slope of the indifference curve. Any particular segment, if we pull out any particular segment and find the slope of that indifference curve, that is the marginal rate of substitution. Let's go ahead and go through an example. Let's put some numbers to it to maybe hopefully kind of clarify some of the stuff I've already mentioned. So if we look at these burgers and tacos example, why? Because tacos are amazing and burgers are awesome. So we're going to use them as our example right now. So if we look at the marginal rate of substitution of burgers for tacos. So it's asking how many tacos are you willing to give up for burgers while still maintaining the same level of satisfaction. So how many tacos are you willing to give up for burgers to maintain the same level of satisfaction? Very simply, we're looking at two goods. How much are you willing to give up of another one to have, or of one to have of another? If you stop and think about it in another example, where you say, maybe you like to consume ice cream and yogurt. How much ice cream are you willing to give up to obtain more yogurt? How much yogurt are you willing to give up to obtain more ice cream? So if we're looking at that, the mathematical equation that goes behind this is a change in tacos divided by the change in burgers. How many tacos are we willing to give up? What is the change in tacos for the change in burgers? So if we look at this indifference curve right here, we're going to look at I2, and we're going to look at the change as we move from M to Q. As we move from M to Q, what is the change in tacos? Well, we reduce the amount of tacos we consume by 2 units. So the change in tacos. Remember that this nice little triangle, anytime you see that triangle in a mathematical equation, that means change. That's that delta, that's meaning change. So we're giving up 2 tacos. We're changing by 2 tacos. We're giving up those 2, so we see that we have a -2 right there. Meanwhile, we obtain 1 burger. We have 1 more burger. So if we do equals tacos divided by burgers, then we can see that this marginal rate of substitution is equal to 2, or -2. Now, why do we do tacos over burgers? Tacos divided by burgers. Well, how do you find the slope of any line? Rise over run, right? So if you remember that back to algebra, geometry, wherever you learned it at, we're always dealing with rise over run. So in this case, we're going to do tacos, because it's on the vertical axis, over hamburgers on the horizontal axis. So what if we move from Q to R now? If we move from Q to R, how many tacos did we give up? Gave up 1 taco. The change in tacos was -1. And if we move from Q to R, how many more burgers are we obtaining? We obtain 1 more burger. So our marginal rate of substitution is -1. Basically what that's saying is, if the marginal rate of substitution is -1, it means we give up 1 taco to obtain 1 burger. Up here, our marginal rate of substitution was -2. What does that mean? It means we give up 2 tacos for 1 burger. Now what if we go back the other way? As we move from R to Q, and we're going to just go ahead and go through the math. As we move from R to Q, how many tacos did we gain or lose? Well, we gained 1 taco. What about how many hamburgers did we gain or lose? Well, we lost 1 hamburger. So as we move from R to Q, we see that our marginal rate of substitution is still equal to -1. What about if we go from Q to M? If we move from Q to M, how many tacos did we gain or lose? Well, we gained 2 tacos. How many hamburgers did we gain or lose? Well, we lost 1 hamburger. So that again is equal to -2, which is the same numbers as what we're finding up here. So you can look at it one of 2 ways. You can either say, well, you know what? As I move from M to Q, or as I move from this point of the curve to this point of the curve, I will give up 2 tacos to eat 1 more hamburger. Or if I move back the other way, I'll give up 1 hamburger to eat more tacos. And if I move from Q to R, or from R to Q, I'm either giving up 1 taco for 1 hamburger, or I'm giving up 1 hamburger for 1 taco. So that's how you calculate this marginal rate of substitution. And very simply, the marginal rate of substitution, it just says, how much am I willing to give up to obtain more of another? Because I have to stay along this indifference curve. And just simply because that is the indifference curve that we are currently on. That's what we're able to obtain. We're attempting to maximize our utility. And if right now, the only utility that we actually can obtain is this 200 utils, and we have to stay along this indifference curve. So all we're really doing is looking at, well, which combination are we going to do, and how much are we willing to give up for another one?